part 4 of our conversation to introduce series is the telescoping series. So at this point, we have learned just what a series is, the general approach to finding the sum of an infinite series, which is the main topic for this chapter. Can we figure out whether an infinite series converges or diverges? So we looked at that, the general approach. That was the first video. Then the second video, we looked specifically at the geometric series and the test for the geometric series. In the last video, we looked at the divergence test, and even when the divergence test is inconclusive, and then what you can do with that and what that means logically. Now we're at the last video here for this section, 11.2, the telescoping series. Personally, this is my favorite series. It's a cool series. And maybe like, where's the name come from? So, maybe you got a telescope like this in like a Happy Meal, or in some at Chuck E. Cheese. You turn in your tokens, right, and you get a little toy like this that collapses. You push the parts together. That's the idea behind the telescoping series. There's going to be this collapsing that occurs, and then we can get an answer relatively simple after we do after we notice that pattern. Okay, so we're going to go through two examples here. Here's my introductory example and then a more difficult one. This is about as simple as a telescoping series gets. It's a great way to introduce it. Let's say the series from n equals 1 to infinity, 1 over n minus 1 over, and that's a plus 1, n plus 1. Okay. So if we went all the way back to the start of this conversation on series, and we look at just the partial sums, what's the first partial sum for the first term? Okay, well, if all we do is plug in 1 and get the first term, that's 1 minus a half. I'm going to leave it like that. This is how I'm going to notice the pattern. Okay, so what's the second partial sum? Well, it would be, the first term plus the second term, right? The second term would give us 1 over 2 minus 1 over 3 if we plug in 2, right? Putting that all together, hey, we can notice, don't those halves cancel out? And all we've got is 1 minus 1/3. And I'm going to leave it like that. So there's this collapsing. Okay, how about the third partial sum? Well, I've got the first term plus the second term plus the third term. Okay, the third term is now 1 over 3 minus 1 over 4. And I see, okay, if I look at all these, how are they going to add up? And I say, well, wait a second, negative a half and positive 1/2, negative 1/3 and positive 1/3. All that's going to come out of it is 1 minus 1/4. So if I take a look at these, 1 minus a half, 1 minus a third, 1 minus a fourth, what's going on? Maybe I could take a guess at the nth partial sum right there. I mean, I think this one is actually simple enough that we could. But what if we didn't? And this is going to be a good strategy for the general case when it's not obvious. Right, let's write it out. S sub n, first term plus the second term, and I'm going to put these dots. At the very end is the nth term, 1 over n minus 1 over n plus 1. And then I'm even going to go backwards by 1 just to see how the cancellation will play out. So if I go backwards by 1, then I've got 1 over n minus 1, 1 over n. So I've subtracted 1 from both of those to go backwards one term. Okay, so how would the cancellation play out? Well, the minus 1/2 and the positive 1/2 would cancel. The minus 1/3 would cancel with the unseen positive 1/3 in the next one. And we'll take that same pattern and kind of, how is it going to play out at the end? And well, we can tell these cancel. We can even tell this would cancel with the one prior to it, right? That's how they're canceling. This one and that, like this one and the one prior. 1/3 and the one prior. This one and the one prior. So that one would have canceled with the one previous to it. And the only thing that's going to be left when we're all done for the nth partial sum, 1 minus 1 over n plus 1. I bet some or most of you could have guessed this pattern by looking at 1 minus a half, 1 minus a third, 1 minus a fourth. Maybe you could have figured this fraction out here. In any case, doing it this way really verifies that you did it right. Okay, so then what? Well, hey, if we've got the nth partial sum, then what we're going to do to find out what the original series adds up to, we'll take the limit of the nth partial sum. That's how we did it way back at the beginning of this section. As n goes to infinity for the nth partial sum, what happens? Well, that part's going to go to 0. Our answer here is 1. So in this case, this series, the original series, converges to 1 by the telescoping series test. All of those infinitely many terms, so many of the ones, all of the ones in the middle cancel out. And it eventually goes to 1 when you add all infinitely many together. Okay. Let's slide this up. We're going to take a look at a more difficult example. This is the last example of the section. Letter F, converge or diverge, and if it converges, to what? Now this one's kind of cool. 1 over n squared minus 1, and we're starting at 2. Turns out for a series, you can start wherever you like. Right, for a geo, we always start at 0, geometric series. A lot of them start at 1, but we could start at 2. Okay. All infinitely many terms. So let's kind of just go through. This is a brand new problem. What method are we going to use to show whether that converges or diverges? And you might think, well, should we apply a geometric series? That definitely does not fit the geometric series pattern. That's just a no. We can't go anywhere with that. Hey, maybe the divergence test. Let's take the limit of our nth term. Well, if we take that limit as n goes to infinity, we get 0, but that's no good. The divergence test is inconclusive. So we tried the geo series, we tried the divergence test, and neither of those are going to do it. Luckily, we've got another option at this point. Let's try the telescoping series. And think, well, telescoping series is always going to look like a term minus another term, right? Like our previous one. It's got to fit this form. A term minus another term. So there's this cancellation. And we don't have that yet, but we can if we use, everyone's favorite technique to turn things into smaller fractions. We'll use partial fraction decomposition on 1 over n squared minus 1. So I'm not going to show you all the details of these partial fractions. We've done this plenty of times. What I will show you is the factorization. Okay, so hopefully we all know that. And then it breaks up as a over n minus 1 plus b over n plus 1. We would go through the steps, and we would arrive at these values of a and b. So I'm just going to tell you that. There's some work in the middle. Let's not spend time doing that. There's my a, there's my b. So I'm going to go and plug those in. I think we can get rid of this page now. I'm going to plug those back in. Plug in my a and my b, and I'm subtracting now since b is negative. Okay. To make things a little easier, I'm even going to pull out that 1/2. Let's think of it as 1 over n minus 1 minus 1 over n plus 1 with the 1/2 out front from n equals 2 to infinity. Okay, great. Now it looks like the beginnings of a telescoping series where I've got one term minus another. So let's go for it. We could really take our time like that last example, but I think we're going to be better off if we just dive in. Okay, so the sum of my nth term, I'm going to forget about the 1/2 for the moment, just focus here. What's the nth partial sum? So I'm going to put maybe like a big bracket. No, we're good. What's the first term here? So, well, it's actually started as at n equals 2. So plugging in 2, 1 minus 1/3, right? Okay. What's the second term? That would be n equals 4. 1 over 3. Excuse me, that'd be n equals 3. Okay, n equals 2. Now n equals 3. 1/2 minus 1 over, if n equals 3, 4. Ooh, okay. I don't see any cancellation yet. Let's keep going. The next term, so that was 2, 3, now plugging in n equals 4, and now finally I've got 1/3 minus 1/5, and I can see those 1/3 are going to cancel out. So it's not back-to-back terms. I actually skip a term and go all the way to there. How about another one just to show this? So let's see, that's n equals 2, 3, 4, now n equals 5, 1 over 4 minus 1 over 6. And I can see the 1/4 is going to cancel. Okay, so it looks like the second term cancels with the first term 2 steps later. So let's think, is this 1/5 going to cancel out? It will if we do one more. Is the 1/6 going to cancel out? If we do 2 more, that will cancel. Maybe looking back, is the 1 ever going to cancel out? Well, no, that 1's never going to cancel. How about the 1/2? No, if that had canceled, it would have been back previous, right? It would have been back this direction. That's not going to cancel, but all these other ones do. Okay, so that's nice. Plus, now I'm going to leave a big bracket here and another one. I'm going to go all the way to the end. What's the very last term? Well, the nth term is just going to look exactly like that. I think I gave myself too much space. There's the nth term. What's the term previous to that? So I can take both of these and subtract 1 and minus 2, 1 over, subtracting 1 is just 1 over n. How would those cancel out? Let's see. Well, the way the pattern works, if we're working off the back end, will this first term cancel? Yes, it would have canceled from 2 back this direction. How about the 1 over n? No, because it would need to cancel with this 1 over here, but there isn't one, so that's going to stay. This 1 over n minus 1 would. That one will not. So when we're done, that all makes sense. I've got it quite a bit further for some reason. The 1/2 is going to stay. The 1 is going to stay. The 1/2 is going to stay. All these others cancel. The 1 over n, I wrote 1 plus there. Oh, gosh. Terrible, terrible. These are minuses. Okay, so that minus 1 over n is going to stay. The minus 1 over n plus 1 is going to stay. There's my nth partial sum. At that point, the hard work is done. I figured out the pattern and how this thing collapses. All I got to do is take the limit of my nth partial sum. So I'll say the entire series, all those terms add up to this limit. Of course, I need to multiply by 1/2. That 1/2 from earlier. Well, what's going to happen here? As n goes to infinity, that goes to 0, that goes to 0. All I've got is 1 plus 1/2. 3 over 2 multiplied by my 1 over 2, 3/4. There's my answer. This thing converges to 3/4 by the telescoping series test. If you missed some of that logic, obviously go back, listen to it again, or we can talk about it in the live meeting. I love telescoping series. That's the end of 11.2.